My dear students, once again I welcome you all to my channel Abrar Sir classes. Today we'll be seeing some important problems on Newton's laws of motion. This is part 10 of the video. Kindly visit the previous videos also so that you can understand the problems very clearly. This is the first problem. It is saying figure shows a light spring balance connected to two blocks of mass 20 kg each. This is 20 kg, this is 20 kg. Okay, right. The graduations in the balance measure the tension in the spring. This is the spring balance. This is called the ring. This is called the hook. This is the pointer. And this is called graduated scale. The graduations in the balance measure the tension in the spring. Okay, what is the reading of the balance? See, whichever is connected to the hook, okay, that is measured by the spring balance. Okay, the tension in this string will be T1. If we call this as T1, this is T1. T2, T2, this is force. 20 into 10 is 200 newtons, and this is 200 newtons. Okay, now we are supposed to calculate reading of the balance. If we calculate tension here, we can measure directly the reading of the balance. First, let us find if any acceleration is there or not. How to find the acceleration? Now, consider this as system boundary. If I take this as system boundary, which is chalane wala and which is rokne wala, one and the same. That is, this is A part solution I am doing here. Okay, solution for A part. What is the reading of the balance? Okay, chalane wala minus rokne wala. Okay, 200 minus 200, that is equal to mass into acceleration. Therefore, acceleration is 0 here. Forces are balanced. Forces are balanced. Since there is no acceleration here, this whatever the weight is connected to this string, which is connected to the hook of the spring balance, gives the reading of the spring balance. That is tension. What is the tension here? T1 is nothing but T1 is equal to how much? Directly 200 Newton. This is the answer for the first one. Okay, that is, if you want to convert this into kg, divided by 10, you will get T1 is equal to 20 kg. Hope you understood. This is the reading of the spring balance. Now, will the reading change if the balance is heavy, say 2 kg? Now, I have written the answer here. If the balance is heavy, the reading will not change because the weight of spring balance does not affect the tension in the string. That is very, very important. Okay, no, the answer is no. Will the reading change if the balance is heavy, say 2 kilogram? Answer is no. Reason I have written here. If the balance is heavy, the reading will not change because the weight of spring does not affect the tension in the string. Now come to the C part of the question. What will happen if the spring is light but the blocks have unequal masses? If they have unequal masses, let us say this is m1. Okay, let us say this is m1. Let us say this is m1. If it is m1, what will be the weight? m1 g, and this, if this is m2, here m2 g, weight will be m2 g. Let us say, okay, let us say m1 is greater than m2. Let us say m1. Where will be the acceleration? Acceleration will be here, this side. Okay, yeah, right. Let us use the system boundary technique once again to calculate acceleration, which is chalane wala. This is chalane wala. Okay, m1 g minus rokne wala will be this one, m2 g, is equal to total mass into acceleration. That is m1 plus m2 into a. Now calculate acceleration. acceleration is equal to how much? Directly I can write m1 minus m2 g divided by m1 plus m2. Okay, I got it. Now let us find the tension. How to find the tension? Always tension will be there this side away from the block. Okay, I will use this system to calculate tension. Okay, T1. Okay, let us find out T1. How much is T1? So this one m1g in the direction of acceleration, m1g minus चलाने वाला minus रोकने वाला will be T1, that is equal to mass into acceleration, that is m1 into a mass of this block. Okay, now from here we can calculate tension in the string. Therefore T1 will be equal to how much? m1g minus m1a, that is equal to m1, I can take common here, g minus of a, that is equal to m1 g minus of, in place of a I can write what? m1 minus m2 into g divided by m1 plus m2. In place of a, write down this one. Okay, whatever is there here. Understood? Hope you understood. Now let us find out the value of T1. Here itself I will write T1 is equal to m1, I will take, okay, already that is taken common. Now if I take m1 plus m2 as LCM here, m1 plus m2, what I can write? I can write this is m1, okay, m1g, okay, plus m2g, okay, minus m1g minus into minus plus m2g, okay, which gets cancelled here, this and this gets cancelled, m2g plus m2g is 2m2g. Okay, therefore tension will be equal to what? 2 m1 m2 g divided by m1 plus m2. Okay, this is T1, tension in the string 1. Okay, that is the reading of the spring balance. Okay, hope you have understood. So 2 m1 m2g divided by m1 plus m2. Hope you have answered all the questions here, A, B and C. Let us go to the next problem. It is saying if acceleration of m1, this is m1, how much is this? 2 kg. m1 is 2 kg. Okay, m2 is how much? Okay, it is accelerating towards right. Okay, this is, I will call this as a1, and find out acceleration of m2. m2 is how much? This is 3 kg, which is greater than 20 newton. I will take this one, a2. We are supposed to calculate what? Find out acceleration of the block m2 of the mass 3 kg. Okay, now a1 is given. How much is a1? a1 is given as how much? 2 meter per second square. Now we are supposed to calculate a2 is equal to question mark. a2 is equal to question mark. Now I will use system boundary. I will use system boundary. If I use system boundary, see here, okay, this is what? Spring force kx, and this is all spring force kx. Okay, these two internal forces gets cancelled, that already we know. Okay, चलाने वाला will be 20 minus रोकने वाला is 10. Okay, is equal to mass into acceleration, that is, okay, m2 a2 plus of m1 a1. I can write. Okay, how much is 20 minus 10? 10 is equal to m2 is how much? m2 is 3 into a2 we do not know, plus m1 is how much? 2 into a1 we know, that is 2. That is equal to 10 is equal to 3a2 plus of 4. 3a2 is equal to 10 minus 4 is 6. a2 is equal to how much? 2 meters per second square. a2 is also how much? 6 by 3 is 2 meters per second square. Hope you have understood. This is called system boundary technique. Okay, this is called system boundary. If you take system boundary, internal forces gets cancelled. Which are the internal forces here? Spring force. Okay, spring force. Okay, that gets cancelled. And in the previous problem also, if I take this as system boundary, that we have learned. Okay, all these internal forces gets cancelled. All these internal forces gets cancelled. Understood? Okay, therefore we have to write चलाने वाला minus रोकने वाला is equal to what? Total mass into acceleration. That already you know. Hope you understood. If you have seen the previous videos, you may understand very clearly. Therefore, what is find out acceleration of the block, that is of mass 3 kg is how much? 2 meters per second square. Now let us do the next sum. Again here it is saying if acceleration of 2 kg block at an instant is 2 milli. Okay, let us say this is what I will call this as m1. Okay, this is a1. Okay, a1 is given. How much? a1 is 2 meters per second square. Okay, find the acceleration of the 1 kg block. This is 1 kg block. Let me call this as m2. Okay, you have to calculate what? a2. a2 I will take in the same direction. a2 you are supposed to calculate. Okay, now let us write the system boundary. Here always spring force will be there. Okay, spring force. Okay, this gets cancelled. Okay, internal forces gets cancelled. चलाने वाला minus रोकने वाला is nothing, is equal to mass m2 a2 plus of m1 a1. Okay, m1 a1. Now here different accelerations are there. Do not write total mass into acceleration. Two accelerations are there here. Okay, because it is connected by a spring, not by a string. If it is connected by a spring, two different accelerations are there. If it is connected by a just string, only one answer. Hope you understood. Okay, therefore we are writing different masses here. 6 is equal to m2 is how much? m2 is 1 into a2 we do not know, plus of m1 is how much? 2 into a1 is 2. That is 6 is equal to a2 plus of 4. a2 is equal to 6 minus of 4, that is equal to 2 meters per second square is the right answer. Hope you have understood. Okay, this is the right answer. Now let us go to the next problem. Okay, these are the three masses. These two masses are connected by a spring. Okay, this is spring. Okay, this is string. Okay, this is what? String. What will be there in the string? In the string, tension will be there. In the string, tension will be there. Okay, same string, same tension. Okay, different string, different tension. This is what? Spring. This is what? Spring. It is written like this. Okay, spring, and this string is just like this. Hope you understood. Okay, here spring force will be there, kx, and here also kx. Okay, this is 2 into 10 is how much the weight? Force, that is 20 Newton, and here 1 into 10 is 10 Newton, and here how much? 3 into 10 is 30 Newton. Okay, this is force due to gravity. Okay, weight, that is 2 into 10 mg. Okay, for mg force this is. Okay, now let us what from the fixed pulley. This is a pulley. This already is a fixed pulley. From the fixed pulley, masses 2 kg, 1 kg, and 3 kg are suspended as shown in the figure. Okay, find the extension in meter in the spring. If spring constant they have given, spring constant is 100 Newton per meter they have given. Neglect the oscillation due to spring. Okay, first let us find. Okay, the acceleration will be downwards here. Acceleration will be downwards. Okay, now just see here. Now let us take this as what? This is system boundary. System boundary. If I take system boundary, all the internal forces gets cancelled. All the internal forces gets cancelled. Therefore, this kx and tt gets cancelled. Okay. Now chalane wala is 30 plus of 10. Rokne wala is how much? That is minus of 20 is equal to mass into acceleration. How much is mass? 2 plus 1 plus of 3 into acceleration is how much? A. Okay. Now 30 plus 10 is how much? 40 minus 20 is 20. That is equal to 2 plus 1 is 3 plus 6. A. Therefore, A is equal to how much? 20 by 6. That is equal to 10 by 3 meter per second square. Now what we are supposed to calculate? You are supposed to calculate, find the extension in meter in the spring. If spring constant is how much? 100 Newton per meter. Now you are supposed to calculate the extension in the spring. Okay, now let us take up this block. Okay, see the direction of acceleration, which is chalane wala is 30. We got acceleration this much. A is equal to how much? 10 by 3 meter per second square. Now let us find the extension in the spring. Okay, now that is chalane wala is 30 minus rokne wala is the spring force. K is equal to mass into acceleration, mass of this block, that is 3 into A. Okay, now Kx is equal to 30 minus of 3A, that is equal to Kx is equal to 30 minus of 3 into A is how much? 10 by 3, just now we got. Okay, 3 gets cancelled, that is equal to 30 minus 10 is 20, right? Kx is equal to how much? 20. What you are supposed to calculate? X is equal to 20 by K, that is equal to 20 by K is how much they are given? That is spring constant is 100 Newton per meter, that is okay. This is Newton, that is Newton per meter. Newton gets cancelled. X will be how much? X will be equal to 0.2 meter. 0.2 meter. 0.2 meter. Students, hope you understood all these problems. If you like this video, kindly share with your friends. Ask doubts in the comment box. Do not forget to subscribe for my channel and like the video. I wish you all the best for your KCET, NEET and IIT JEE examinations. I wish you all the best. Thanks for visiting my channel, Abrar Sir Classes.